Can someone answer this question? Predict the product of the following reaction. At least tell me what kind of reaction is this? What is the name of reaction is this? I think we discussed this in last class. Do you remember the Friedel-Crafts reaction?
Yes.
Yeah, sure.
Yeah. So what happens? Is this a acylation or alkylation?
Acylation.
Yeah, it's a Friedel-Crafts acylation reaction. So that's happening between the benzene and the phosphozene. So just remember, this reaction is Friedel-Crafts acylation reaction. Okay, so what happens in the Friedel-Crafts acylation reaction? In the presence of anhydrous aluminum chloride, the acetyl group will attach to the benzene. Yes or no? So whatever the bond is there between the carbon and chlorine, that bond will be broken and this entire group will just go and attach to the benzene. Is it correct? Yes, sir. So tell me what will be the product then? So what will be the product? So whatever this entire group is there, this will just go and attach to the benzene. So it will form So see, this entire product will just go and attach here. And whatever the hydrogen that is liberated, that hydrogen will bind with the chlorine and result in formation of HCl. Okay. So what is the name of this? What is the name of this? Benzene with acyl chloride. Benzoyl chloride. Remember this. This is called benzoyl chloride. They can also give you like this C6H5COCl. Okay, so benzyl chloride or this structure or C6H5COCl all are same. Will the reaction will just stop here or will this further happen? So whatever the benzoyl chloride that is formed, now that, yeah, Nitya? So that will react again with the, yeah, Nitya, please tell me. Nitya, your voice is breaking. So see here, what happened? So when the benzene reacts with the phosgene, okay, so here the carbon and chlorine will break the bond. Okay, carbonyl carbon and the chlorine, they will break the bond and the chlorine will take away the electrons. So it will turn out to be the Cl minus. And this carbon will turn out to be positive. So this will go and attack the benzene ring. So when it do that, it will form the benzyl chloride. And the reaction will not stop here. So wherever the benzoyl chloride is there, it will further react again with the benzene. Okay. So whatever the reactant that we are using here, the benzene, this benzoyl chloride will again react in the presence of anhydrous aluminum chloride. And finally, it will form a, what is this? What is this? Is it a, what functional group is this? R, C, double bond O, R dash. So what is
Ketone.
this? It's a
Ketone.
ketone, right? So we call this as the benzophenone, which is nothing but the ketone. So you can write like this: C6H5, CO, C6H5. And the HCl will be formed like a byproduct. Okay, so just remember the benzoyl chloride will further react with the benzene in the presence of anhydrous aluminum chloride. So the Friedel-Crafts acylation will keep on continue till it forms the ketone. Okay, so the benzene will finally turn out to be the ketone. Understood? So next one, predict the following reaction. Do you remember organometallic reagent? So what is this? The benzoyl chloride, or you can also say this is the acid chloride that reacts with the dimethyl cadmium. So this is called dimethyl cadmium. And what is this? It is a benzoyl chloride. So this benzoyl chloride react with a
Class.
hello Blessy. Okay. So see here the benzoyl chloride that will react with the dimethyl cadmium in the presence of dry ether. It will be giving the benzene with C double bond O CS3 plus cadmium chloride. I'll tell you how the mechanism will happen. Okay, so just remember here, it will form, what is this? What is this?
Ketones.
Yeah, in the previous reaction, we got the ketone because both here the benzene groups, whereas here we are using the methyl group. So that's instead of benzene, the methyl group has attached. If instead I have this benzene group and to that the cadmium is attached, then I'll get the benzene ring here. It will form similar like this structure. But here I have a methyl cadmium, dimethyl cadmium. So the methyl group has attached to this. So the same way, whatever the CH3, CD, CS3 is there. So here the bond breakage will happen between the methyl and cadmium. And this methyl group will just go and attach to the benzoyl chloride. So two products will be formed like this. So one methyl group will attach to one benzoyl chloride, the other methyl group will attach to the other benzoyl chloride, and finally form two acetophenones. This is the benzene with a acetyl group. So we call this as the acetophenone. Or you can also call this as methyl phenyl ketone if you want to extract the structure. And the cadmium chloride is a byproduct. Understood? And what is this CS3CD? It is nothing but the reagent, okay? Organometallic reagent, because the cadmium is a metal group and to that the alkyl group is attached. So we call this as the organometallic reagent. Same, this is also Friedel-Crafts acylation reaction, but here it happens in the dry ether. Okay, so just remember how does this reaction will happen? This reaction will happen through the nucleophilic addition reaction. Yesterday we saw what is nucleophilic addition reaction. Okay, the nucleophile will be added. So what happens here? whatever the methyl group is there in the dimethyl cadmium, this methyl group will act like a nucleophile. Okay, so this one will act like a nucleophile. And this nucleophile is adding to the benzoyl chloride and removing this chlorine. So that's why it is called as the nucleophilic addition reaction. Okay, so what happens here? This nucleophile will attack the carbonyl carbon. Okay, electrophilic carbonyl carbon of this benzoyl chloride. Okay, now this chlorine will remove when the nucleophile will come and attack here. Understood? So there is a methyl group is present that acts like a nucleophile. That nucleophile will attack on the carbon, carbonyl carbon. When it attacks, the carbon with the chlorine, the bond breakage will happen, and that result in formation of cadmium chloride. So two chlorines will attach to the cadmium and result in formation of cadmium chloride. And this methyl group will attach to the benzoyl chloride and result in formation of acetophenol. Is that clear?
Yes, sir.
Any doubts?
No, sir.
No, sir.
Bonnie, you understood? The next one. Tell me, what is the answer? We solved this many times. Concentrate on this, that will decide the answer. At least tell me, what kind of group should be present on this benzene so that the electrophilicity of the carbon will increase? Should the compound take the electrons or should it give to the benzene ring the electrons? It should take the electrons from the benzene ring or it should give the electrons to the benzene ring
It
to
should
increase
take,
the electrophilicity. Yes, Nitya?
it should take,
Yeah, it should take the electrons. Okay. So what happens when it takes the electron? The carbon will become positive, right? So the electron bulkiness will decrease on this carbon, so it will turn out to be positive. And we know that NO2 is a good electron withdrawing group. Okay. So just remember, this is a strong electron withdrawing group. Okay. And compared to chlorine, NO2 is the strong electron withdrawing group. Okay. So that this will be this order. And chlorine will be the next electron withdrawing group. And we know the methyl group will contribute. And if it is OCS3, it will contribute further. So this will be the least. Understood?
yes, sir.
Okay. So just remember here, OCS3, it will be showing positive M effect so that it will give so much, gives highest electron density to the benzene compared to any other. Okay. Compared to methyl group, this OCS3 will give more electrons to the benzene ring. And when you give more electrons to the benzene ring, the positive charge on this carbon will decrease and the electrophilicity will decrease. So the order is this way. Okay, so let's do nucleophilic addition reaction of the carbonyl compounds. So the second kind of chemical reactions that we'll be seeing in the aldehydes and ketones. So we'll be seeing the addition of hydrogen cyanide, addition of sodium hydrogen sulfide, addition of Grignard reagent, addition of alcohols, addition of water, addition of ammonium and its derivatives. So these are the important chemical reactions are there. Okay, so let's see one by one. So nucleophilic addition reaction of carbonyl compounds with the hydrogen cyanide. Okay. So what happens here? The hydrogen cyanide undergoes nucleophilic addition reaction. Okay. So which one will go? This hydrogen cyanide will go nucleophilic addition reaction with the carbonyl carbon. Okay, that is found in the aldehydes and ketones. We know the aldehydes and ketones, they contain this carbonyl group. Okay, so to this carbonyl group, the cyanide will act like a nucleophile. Before, if we see here in these reactions, here the benzene ring or the methyl group acts like a nucleophile, and that is attached to the carbonyl carbon. But here the cyanide will go and attach. Okay, so whatever the cyanide is there, that cyanide will go and attach to the carbonyl carbon. Is that clear?
Yes, sir.
That will result in formation of the cyanohydrins. Okay, so the product will be cyanohydrins. We'll see what is that. Okay, and next one, if you see the structural consideration, we know that the carbonyl group in the ketones is highly hindered. What is ketone? The alkyl group, carbonyl carbon, and then alkyl group. So here the carbonyl group is surrounded with the two different bulkier groups. Yes or no? This is a bulky group, and this is another bulky group. Because of this bulky group, what happens? It is highly hindered. That means whenever the nucleophile try to come and attack this carbon, whenever a nucleophile try to attack this carbon, it becomes very difficult because it is surrounded with these bulky groups. So it is very impossible for this nucleophile to approach the ketones. But if you take the aldehydes, it can easily attack the carbonyl because it is just only surrounded with a single bulky group. But on the other side, you have a smaller group. Understood? So see here, ketones in which the carbonyl group is highly hindered, they will not participate in the reaction. This you should understand. Okay, because the ketones, they are highly hindered due to the steric hindrance, they cannot participate in the nucleophilic addition reaction. Is that clear?
Yes, sir.
Okay. That's one more thing. And next one, the reaction occurs slowly with pure HCl. Okay. Hence catalyzed by a base. Okay. So for this reaction to happen, we need to use a base catalyst that will accelerate the reaction. Okay. Here the base, whatever the base that we are using, it will speed up the reaction. Okay. And here the cyanide, the Cn minus, will act like a strong nucleophile compared to the OH minus ions. We know the OH minus ions are good nucleophiles. Compared to the OH minus ions, the cyanide ions are much more stronger nucleophile. Because of that reason, because of the cyanide, which is very strong reaction, it will be helpful for formation of the cyanohydrins. It will be helpful for nucleophilic addition reaction and result in formation of the product cyanohydrins. So this property, the cyanide being the strongest nucleophile, it will be very crucial for the formation of this cyanohydrins. Okay, which is a valuable intermediate. We'll see how does this intermediate will be formed. Let's suppose I'll show you the reaction. So is these points clear for you? So why the ketones will not participate in the reaction? And why the reaction takes place slowly, and for that we need the base, and why the cyanide being a very strong nucleophile is very helpful for formation of the cyanohydrins. Is that clear?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, guys. So let's see how does the mechanism will happen. First, suppose you take a cyanide, HCN, and when it reacts with the OH minus hydroxyl group, it will result in formation of Cn minus plus water. Okay, so there is a bond breakage will happen between the carbon and the hydrogen, so that this hydrogen will go and attack the OH minus, result in formation of water, and you will be getting the Cn minus. Okay, now this Cn minus will attack the aldehyde group. Okay, so whatever the Cn minus that is formed, it will try to attack this carbon. and result in formation of a tetrahedral intermediate. So carbon O minus and Cn. Understood? So this cyanide as attached. For that O will take out the electrons. So it will be turned out to be O minus. And now this Cn will just come and attack and make the bond. And whatever the R and H is there, they will just attack. So that's how it will be forming an intermediate molecule. Is that clear? I'm just writing in a one single step. So this one is called as tetrahedral intermediate. You just need to understand what is our nucleophile. That's it. If it is nucleophile, then this will attack this carbon. Okay. And that will just join this and it will form. Now you will be doing the protonation. So we'll be doing the protonation, and whatever this O is there, O minus, you will be attaching the hydrogen. So it will turn out to be the OH. So that's it. Very simple reaction. So it will form C, OH and Cn. So it could be the R and it could be the hydrogen as we are taking the aldehyde here. Understood how this has formed? Any doubts?
No, sir.
So we call this as a cyanohydrin. So just remember, this is 1, this is 2, and this is 3. Okay. So what happened here? We are taking an aldehyde. That aldehyde is containing the carbon double bond oxygen. So this carbon will be attacked by a nucleophile. What is nucleophile? Nucleophile is a compound that attracts the positive charge. That will be attracted to the positive charge. So if you see the C double bond O, the bond double bond will break, and whatever the electrons are there, they will move to the oxygen. So the oxygen will turn out to be partially negative, or it will turn out to be completely negative, and the carbon will turn out to be positive. Due to that reason, this is a positive charge, and the nucleophile love this positive charge. So this nucleophile will come and attack here. So that's how it will be forming the bond here between the carbonyl carbon and CN, which is a tetrahedral intermediate. Now, this O minus, we need to balance this charge. So you will be doing the protonation so that it will be having the OH. So that's it. We call this as a cyanohydrin. Understood?
Yes, sir.
Yes, sir.
See, here ketones will not participate under this reaction, but they can also participate, but that's very less. Just remember this thing. Okay. You may think again that ketones will never participate in this kind of reaction. No, they will do, but it's very less. Understood? Aldehydes are somewhat favorable compared to the ketones. So now tell me, what is the answer for this? Banu, are you in the class? Banu Tejashwini. Come on, guys, answer quickly. This is very simple thing.
Yes, sir, I'm in the class.
Have you understood the previous reactions, whatever I explained?
So should it be either A or C? I'm getting confused between two of them.
So I think it's C, sir.
The answer is C. Okay, you may doubt that C2H5, C double bond. Okay, but cyanohydrins will be more favorable for the aldehydes and then ketones. Just remember this. So aldehydes and then ketones. So what is a ketone here? It's a option C.
Option
Okay,
C.
so just know that the cyanohydrins, okay, whatever the hydrogen cyanide is there, that will be added to the carbonyl group of aldehydes or ketones. Okay, so for the best cyanohydrin to form, we'll choose the aldehyde and then ketone, and then you can go to this carboxylic group. Okay. So next one. This may look like very big, but it's a very simple one. So just think clearly.
Sir, option B.
Okay. So Nitya saying option B. B for ball, right?
No, sir, no, sir, no. Sir, no, sir. I think it's not B. I got confused.
So is it C?
Okay, Shrikar is saying C. What about the others? Yeah, Sharon?
Delhi. D.
Okay, Sharon is saying D. Mandara, Nitya,
I
Banu,
think it's C. I think it's C, sir.
what you're thinking? Mandara?
I think it's C, sir.
C. Okay, what about you, Banu?
So C, sir.
Okay. What about the others? Nitya?
Sir, will it be D?
Yeah, the answer is D. See, what's happening here? You take a R, C double bond O, R dash. Okay, in the presence of HCN or KCN. Either you take the hydrogen cyanide or potassium cyanide. Okay, so what happens now? This cyanide ion will attack the nucleophile. Okay, sorry, this cyanide ion will act like a nucleophile and attack the carbonyl compound. Yes or no? So this CN will just go and attack this one. How does this will happen? First, suppose let me draw the full thing. So this will turn out to be RCO minus R dash. And then the cyanide will come and attack this carbon. So let's say the cyanide is attacking this CN, the carbon. Okay, cyanide is attacking this carbon. That will result in formation of carbon. R group is present, R dash group is present. Or let's draw like this, R, C, R dash. So as the cyanide is attacked, first O minus and then Cn will be formed. And then I told you protonation will happen, that will convert to be OH. So this is the group. Understood? So the answer for A is this one. Now what happens here? So the B. One second. So by using the B, you will be getting here the CHNS2. Okay, so whatever the cyanide is there, the cyanide is replaced with the CH2NS2. Okay, so that means it should be a very strong reducing agent. And among all this, which one is a very strong reducing agent?
LiAlH4.
It's a lithium aluminum nitrate. Okay, LiAlH4. LiAlH4 is a strong reducing agent, so the option is D. Okay, so in the presence of LiAlH4, it will finally give carbon OH. Understood? So whatever the cyanide is there, the cyanide is replaced by a strong reducing agent. Is that clear? Why the option D is correct?
Yes, sir.
Even we
Yes,
saw
yes.
this lithium aluminum hydride, how it is acting like a strong reducing agent. I told you in the previous classes. So just know that, okay? So whatever the lithium aluminum hydride is there, I'll give you few more points. It will convert into the primary amine. So whatever this amine is there, it's a primary amine. It's a powerful or strong reducing agent. Okay, so the hydroxyl group will just remain, it will not change, but the final group product is an amino. One second, guys. This is a amino alcohol. Okay, so why alcohol? You can see here the functional group OH is present and the amine group is present. So it's a amino alcohol, which actually a primary amine. So you just need, remember this thing. So whatever the cyanide is there, in order to replace this, you need a very strong reducing agent, then only it can convert into this. For that, we need the lithium aluminum hydride. So that can replace the cyanide and it can attach the primary amines. So let's see the next one. So addition of sodium hydrogen sulfate. Nucleophilic addition reaction of the carbonyl compounds with sodium hydrogen sulfate. What is sodium hydrogen sulfate? It is nothing but the NaHSO3. So NaHSO3 is called as the sodium hydrogen sulfate. Okay, so what happens here? The nucleophilic addition of this sodium hydrogen sulfate will happen to the carbonyl carbon. Okay, so whatever this NaHSO3 is there, in that the nucleophile will attack the carbonyl carbon. So this is a very characteristic reaction for the aldehydes and ketones. You will be seeing this in aldehydes and ketones. Okay, so it results in formation of an intermediate. On proton transfer, it will be finally turning out to be bisulfite addition compound, or you can also call it as the crystalline salt. So what's happening here? First, suppose let's see the initial addition. So whatever the nucleophile in this NaHSO3, it will break down into Na plus HSO3 minus. So which one acts like a nucleophile here? Na plus or HSO3 minus? Is nucleophile positive charge or negative charge?
Negative.
It's a negative charge. So here the HSO3 is our nucleophile, and this nucleophile will attack the carbon. Okay, so that's what happens. it's a initial addition is whatever the nucleophile HSO3 ion is there, it will attack the electrophilic carbonyl carbon. Okay, that result in formation of a bond between the carbon and sulfur. Just remember this. Okay, so the bond formation will happen between the sulfur and carbon. And if you see whatever the double bond is there, it is converted into the single bond. Okay, so between the carbon and oxygen, whatever the double bond is there, the electrons will move to the oxygen and the oxygen will turn out to be partially negative and the carbon will be turned out to be partially positive. Now this positive negative charge HSO3 minus nucleophile will come and attack this carbon. So the double bond has turned out to be a single bond and result in formation of this compound. Now the proton transfer will happen. Okay, and result in formation of a crystalline salt that is called as the bisulfate addition compound. Okay, so this contains the SO3 so it's a salt, and attach it to the OH, and there is a R group or hydrogen, or it could be a R as well if you are taking the ketone. If you are taking the aldehyde, it will be hydrogen. Understood? First, suppose this is ketone when both are R. Hydrogen, if it is present, we call this as aldehyde. So based on that, your product will be formed. That's why I'm not putting anything here. That shows that it could be aldehyde or it could be ketone. Is that clear?
Yes, sir.
So next one, addition of Grignard reagent. Okay, so how does this reaction will happen? So there's a carbonyl compound that's containing C double bond O, and there is a Grignard reagent RMgBr. We know this R could be alkyl, or it could be the alkyl, or it could be the aryl group. It could be a ring or it could be a chain. If it is chain, we call it as alkyl. If it is a ring, we call it as aryl. Okay, like benzene ring or a straight chain of the carbon, alkyl. So how does this reaction will happen? You can see here, the bond breakage will happen between the alkyl group and the MgBr. Okay, so there is a addition will happen. So first one is the addition followed by the protonation. So remember, this is the step 1 and the step 2. In the step 1, addition will happen. So what happened? For the Grignard reagent, the bond breakage will happen between the R group and the MgBr. Okay, and result in this MgBr will go and attach to the oxygen, and whatever the R is there, it will go and attach to the carbon. If you remember this, we have talked when we discussed about the Grignard reagent. Okay, so there is a C double bond O and there is a R MgBr is there. So there is a bond breakage will happen, and now this MgBr will turn out to be positive and the R will turn out to be negative. So this R group will just go and attack this carbon, and whatever the MgBr is there, that will go and attack the oxygen and result in formation of OMgBr and R. And you do the protonation and it will turn out to be this. And whatever the MgBr O, it will be removed. The bond breakage will happen here. And hydrogen will go and attach here. Is that clear? So for that, we need to treat with the water and dilute acid. So the dilute acid will provide this proton. H plus is nothing but the acid. Okay, it should be a dilute acid. And this is the intermediate step. We call it as the alkoxide. So this is called as the alkoxide. Intermediate. And result in formation of this magnesium bromide hydroxide. Okay, this is magnesium bromide hydroxide. And there is a alcohol. So this is nothing but a alcohol. Is that clear? How does this reaction has happened? If you have any doubts, let me know. I'll clearly explain in detail.
Sir, could you repeat once?
See, this reaction will happen in 2 steps. Step 1, we called it as addition. What happens here? The nucleophilic addition will happen. So whatever the Grignard reagent is there, RMGBr, the bond breakage will happen and result in formation of R minus and the MgBr. Okay. Now this R minus will make a bond with the carbon and result in formation of carbon-carbon bond. And whatever the MgBr is there, it will go and attach to the oxygen and result in formation of a alkoxide intermediate. Now this alkoxide intermediate will undergo protonation in the presence of water and the acid. So whatever this OMGBr is there, the bond breakage will happen between the OMGBr and the hydrogen will just attach here. Okay, and the MgBr OH will just remove like a byproduct, which is a magnesium bromide. So if you see here, the reaction has started with the aldehyde or ketone and result in formation of an alcohol. And what kind of alcohol is this? It could be the tertiary alcohol or it could be the secondary alcohol. If you are using the, this is another important thing you need to remember. If you are using the aldehyde, let me write here. If you are using the aldehyde, it results in formation of the secondary alcohol. If you are using the ketones, it results in formation of the tertiary alcohols. You can understand why it could be tertiary alcohol. For suppose this is R and this is R. So then this case, this will be R, this will be R, this will be R. So it's a tertiary alcohol. Or if it is a aldehyde, this will be hydrogen. And you see here two alkyl groups are there. So this is a secondary alcohol. Is that understood? So why the aldehydes will form secondary alcohol? Why the ketones will form tertiary alcohols?
Yes, sir.
Yes, sir.
Okay. So next one, tell me what could be the product? Just now we did.
So it will be alcohol,
Which
3-degree
alcohol?
alcohol.
It's a tertiary alcohol. Okay. So it result in formation of this. I'm not writing full thing, but yeah, this will be like this. First it will form OMGBr and then we do the protonation. This is a nucleophilic addition and this is the protonation, second step. Result in formation of plus MgBr OH. Is it clear? Anyone have doubts? This is the intermediate and this is the final product, which is a tertiary alcohol. Bono, you are getting this? Banu Tejashwini,
Yes, sir.
have you understood this?
Can you explain again, sir?
Okay. See, I'll explain in detail. Just listen again. I'll explain here. So if you remember what I'm saying, first suppose I'll explain in steps. So first one, actually this reaction is called as the addition of Grignard reagent. So in this, either we'll be taking the aldehyde or ketone. What is aldehyde? It is nothing but the carbon which is attached to R group and attached to hydrogen with a double bond O. So this we call it as the carbonyl group. This carbonyl group, on one side it is attached to the alkyl group, on the other side it is attached to hydrogen. We call this as a aldehyde. If it is a ketone, the carbonyl group attached to two different alkyl groups. So we call that as a ketones. Okay, so that's the basic difference between an aldehyde and ketone. Now what we are doing, we are reacting this with a RMGBr. Okay. So I told you one thing in the yesterday class. If you see the carbon and double bond oxygen, here the oxygen is an electron withdrawing group. So it will try to pull the electrons towards it and it will become partially negative or negative by taking the electrons. And the carbon will turn out to be the positive. Yes or no? And you take a nucleophile. Nucleophile is a negatively charged molecule. It is a negative and it will love the positive charge. So it will attack this carbonyl carbon. So result in formation of carbon nucleophile oxygen. Okay. So if you take the Grignard reagent here, in the Grignard reagent, so whatever the alkyl group and magnesium bromide is there, the bond breakage will happen and result in formation of R negative and MgBr positive. Okay, so this is our nucleophile. This nucleophile will attack this positive carbon. And this MgBr plus, it is a positively charged. So this will attack the oxygen and result in formation of carbon, which is attached to the R group and it is attached to the oxygen. That oxygen is attached to MgBr. So OMgBr. Okay. And if it is a aldehyde, the other things will be R and H. If it is a ketone, it will be R and R. You understood this, Banu?
Yes, sir.
Okay. So it
Yeah.
will result in formation of this structure. Now what happened? You will be doing the protonation. That's the second step. You do the protonation. That will be done with the water and H plus. What happens now? Whatever this OMGBr is there, it is completely removed. And in that place, the OH group will attach. Okay. Or whatever this H is there, it will attach and result in formation of carbon. And see here, this is R, this is R, and this is R. Now, whatever this OMGBr is there, it completely be eliminated and OH will attach here and result in formation of an alcohol. Okay. So we call this alcohol as a tertiary alcohol because this carbon is attached to 3 different alkyl groups. Okay. So that happens when you are taking the ketone. But if you take the aldehyde, it will not contain 2 R's. It will contain hydrogen here. You see here, 1 R and 1 H. In ketones, both are R. So this is R, H, R. If you see here, there are 2 alkyl groups are attached here. So this will be secondary alcohol. So that's how aldehyde will give the secondary alcohol. Ketone will give the tertiary alcohol. Is that clear?
Yes, sir.
So that's how we got here tertiary alcohol because this is a ketone. If instead of this R dash, if I have the hydrogen, this will become aldehyde. And instead of having R here hydrogen, so that will be secondary alcohol.
Yes, sir.
Okay. Is
Yes,
it clear
sir.
for everyone?
Yes.
Yes, sir.
Yes, sir.
Okay, great. Yeah, tell me what is this? What is the compound? First of all, it's a by itself, you can say
Secondary alcohol.
Option A.
it's a benzaldehyde. Okay, the benzene, or you can say like this. So this is a benzaldehyde. So benzaldehyde result in formation of the secondary alcohol. Okay, I'm not drawing anything. You understood everything. The main important thing is whether it's a ketone or aldehyde, you should notice that. Okay, and then you will be doing the nucleophilic addition and then protonation. So next one, addition of monohydric alcohols on the aldehydes. Okay, so what is this? It's the conversion of an aldehyde to an acetal and this will takes place in 2 steps. Okay, and there is a intermediate which is a acetal, which is a very unstable. First, suppose let's see how does this reaction will happen. Okay, so first the initial reaction. Okay, so whatever the aldehyde group is there, so this is the aldehyde group where the carbon is having one side R, on the other side hydrogen is present. Okay, so this aldehyde group, it will react with the alcohol in the presence of hydrogen chloride, which is a catalyst, acid catalyst. Okay, so what happened? There will be initial reaction. In the initial reaction, aldehydes reacts with alcohols in presence of HCl catalyst, acid catalyst. Okay, that will result in formation of a intermediate. That intermediate is called acetal. Understood? So the same thing will happen. Now the bond will go and result in formation of the O minus, and whatever R and OH is there, they break the bond and result in formation of OH minus R positive. Now this positive will attack the oxygen, and whatever this OH minus, it acts like a nucleophile and result in formation, make the bond with the carbon. So this is the very basic thing that's happening for everything. You just need to understand when ROH is there, which one will turn out to be positive, which one will turn out to be negative. As we know, R is positive, and we know the carbon and oxygen will be negative, carbon will be positive. So the R will attack the oxygen, OH will attack the carbon. So that's how it will form the acetal, which is a very unstable. Okay, and again the same reaction will happen further with the same alcohol and HCl. Okay, so the unstable acetal will further reacts with another molecule of this alcohol, and in this the water molecule will be eliminated and result in formation of a very stable acetal. Okay, so just remember here, so the aldehydes will attack with the monohydric alcohol. This is very, very important. We are taking monohydric alcohol. That means 1 degree alcohol, where 1 R is attached to the OH. It's a primary alcohol, you can say. And here the acid HCl is acting like a catalyst. You will be getting the acetal, which is very unstable, and then result in formation of a stable acetal by losing the water. So the water comes as a byproduct. Okay, so first one is the initial reaction, that is formation of this unstable acetal. Second one is formation of the stable acetal. Okay. Is that clear?
Yes, sir.
Okay. See, the chemistry will be very easy if you understand the mechanism. If you try to mug up, you will never remember it. So now you can simply understand whenever you see carbonyl group, always remember whatever the double bond is there, it will break and it will turn out to be minus and positive. And whatever the reactant, the other reactant is there, for suppose here alcohol, ROH, it will break the bond and it will turn out to be R positive and OH negative. So this will attach to this will attach to this. Or you take another one, MgBr, okay, RMgBr. So in that condition, this will turn out to be negative, this will turn out to be positive. So reverse will happen. Okay, that you should be careful. Which one will turn out to be cation and which one will turn out to be anion. Is that clear? So you can easily form the products. Okay, then if you have any doubts, please ask me. If not, we'll just wind up for today. Okay, then good night, guys.
Thank you.
Good night,
Thank
sir.
you, sir. Bye.
Thank you, sir.